Thank you, Vaishnavi. The session was quite impressive. Ladies and gentlemen, let's move towards the next session of the day. And the next topic is automating inside pipelines. Well, ladies and gentlemen, to take you through the next session, we have Mr. RAGHAVAN KIRTHIVASAN, Senior Manager at AIG Science. Raghav is part of the data science team in AIG and has experience of 14 years, focused primarily on analytics and building predictive models. Most of the experience has been in BFSI space, working in companies such as American Express and Royal Bank of Scotland, where he was managing the risk strategy for consumer loans and cards portfolio. He has worked on a variety of business problems by utilizing a wide range of math, stat techniques. Prior to joining AIG, Raghav was the analytics leader for insurance RNA team at VNS. So ladies and gentlemen, let's give a huge round of applause for Mr. RAGHAVAN KIRTHIVASAN. Over to you.
Can everyone hear me? Yeah, good. Hi, as introduced already, I'm Raghav. I'm part of the science team at AIG, right? I also have with me Vishwanath Ramdas, who's part of the AIG team. And what we'll be walking through today is how do we automate the entire insights pipeline, right? Starting from the time that you start off with your data, right? How do you make sure that the insights that you're getting from the data is fast, right? Starting when you want to look at your data quality, right to the point when the model actually is actually started to build, right? And then how do you put it in an environment where the model can be scored and productionized, right? And also, we'll also be talking a little bit about how do you integrate it in such a way so that tomorrow those insights and some of the analysis can be consumed through different APIs, right? And can be integrated so that the business can consume it across different technologies. So that's where the whole focus is going to be, right? That is pretty much what we are going to talk about. Yeah, now it's working. Do you want to just hold it there?
Hey, thanks, Raghav. So I am Vishwanath Ramdas. I am part of the technology services team in AIG, working with the science organization within AIG to kind of look at how we can provide technology support to the science work that's happening within AIG. Most enterprises today are looking towards or are adopting science and analytics in a big way. No wonder we have these kind of seminars and conference where the relevance of analytics has increased exponentially in the past, say, 5 years. What we are seeing based on our work in the last few years is that analytics will truly become relevant. You guys can hear me without the mic? Because I have a loud voice. It's better? It's better? Better now? So you control. So one of the things that we are seeing is that as science becomes more pervasive within the enterprise, the key question that's going to be asked by the enterprise is, as the business environment changes, how can science provide a business-relevant, cost-effective, scalable solution for business? And when we look at our own projects and platforms that we're trying to build, that's one of the biggest challenges that we are seeing as an enterprise in terms of bringing insights and analytics into our business. And therefore, when we look at parallels outside, we see that automation is going to play a significant role. It is being predicted that in 2020, the cost of science is going to be 100x lower than what it is today. What's the reason? It's not that people are going to be earning 100x lesser. They will be earning 10x more in the profession of analytics and science. But it will be that the leverage of technology will give a significant boost to the cost and the speed of adopting analytics into the enterprise. And that therefore it's going to be cheaper. So when we look at the key challenges for data science today, like I said, it's cost, speed, real-time scoring, real-time business rules, and finally the scale and complexity of data. We have seen a lot of sessions today talking about semantics, talking about unstructured data. These are all extreme realities for most business. Data is not in a very elegant form. They have to adapt to the data that they already have. And how do you use that in the process of their business? And what we see, and this is what we're going to talk about today, is largely going to be practical work that we have done, not a blue sky thinking in sense of what else can be done. So we will not cover stuff like robotics, AI, possibly some deep learning algorithms which we are in the process of adopting. So the things are possibly the fundamental foundational building blocks, which basically we see as very relevant to kind of make analytics a lot more pervasive and relevant for our business. 4 fundamental areas we'll talk about. The first is the data pipeline and integration, how analytics teams will have to use automation in that space. Second being preliminary model building and visualization, how that can be automated, which means you don't need too much of human intervention to understand how your data looks before you go and build your predictive or other business analytics models. Then comes the space of scale and compute. Hadoop is a very pervasive platform. How can we use similar distributed computing platforms to adapt to the largely exponentially growing data? And finally, APIs and app integration to kind of truly make analytics seamless and integrated with the business. Today, 90% of all analytics, other than possibly .NET companies, 2.0 companies, are using analytics for human consumption. Right? Very few companies are truly using them in the process of their business process flows, which is automated systems which they exist. So for example, in insurance, our 2 or 3 main process flows are customer management and policy management and claims management. How much are these analytics truly in sync and integrated into those processes is the roadmap we will see in the next few years. Those are the baby steps we are taking. So what we will be talking today is basically going to cover those. The next slide. Yeah. So you want to take
Yeah.
Just. So we will kind of oscillate between myself and Radha is the science guy and the technology services guy. So wherever we see relevance, we will kind of flip over. Okay.
Yeah.
So Radha, over to you.
So thanks, Vish, for that. I think what Vish mentioned was extremely relevant because we want to cover the entire pipeline. So what I will cover here in this slide is what is it that we really do when we start off by building a model, right? There's a lot of time. Typically, if you see a typical model build takes anywhere between 3 to 4 months of modeling, right? Starting from consuming the data, to cleansing the data, to looking at the interaction between different variables and a whole lot of other analysis which goes into it before you decide on the final list of variables, right? And only post that do you really go into a stage where you decide what kind of model do I really want to build, maybe or selecting the algorithm technique. Now this itself consumes more to almost 70% of the time, if you talk about an entire analytics project. Our thought process was that how do we in any way try and bring down this time, right? Because a lot of these processes are manual and fairly repetitive in nature, right? So when you look at interaction between variables, right? I mean, you're just looking at maybe correlation, maybe chi-square, maybe things like that, but I mean, there's nothing new that you're looking at, right? So can you automate things like that and look, and to a large extent, when you're working with the business, give insights at the very initial stage itself. So let's start off with something as simple as univariate, bivariate analysis, right? I mean, you want to look at whether there is information missing in certain variables. If the information is missing, why is that information missing, right? I mean, a lot of people, what they typically tend to do is say, oh, 20% of my data is missing, 15% of my data is missing. And then they say, okay, let me do some sort of treatment and fill in the data, right? But the first question that you really need to ask is, why is the data missing? I mean, is it coming from one particular source, or is there a particular reason because of which the data is missing, right? And only when you have answered the question do you really move on to the point of whether or not I want to treat this data. So what you want to do is, when I say MAR analysis, this is nothing but saying that whether the data is missing at random, right? There is no predefined pattern to the data missing or not, right? So once you analyze that and you come to a stage where you say, okay, I'm fairly confident that the data that is missing is random, right? Can I go ahead and treat it, right? Now there are two aspects to it. When you look at, so you want to look at the interaction between the variables. Now, how do you treat your missing data? There is a univariate way of doing it, there is a bivariate way of doing it. You can look at interactions between different variables, or you can just look at that one particular variable and say, I want to use this variable to possibly fill in the missing values, right? Now, these are things that are basic questions that come up every time when you're doing an analysis, right? Except for unstructured data. Most of the structured data will ask these questions of you. So what we want to do is automate most of this, right? And then come up with algorithms, give you the correlation between variables, right? Look at, and when you talk about MAR analysis especially, what we're trying to do is look at specific categories, right? And then look at the corresponding categories where the information is variable, right? The variable is missing. So let's assume you have age as a variable where information is missing. And maybe you realize that it is just maybe, and you look at occupation as an example, and you figure out that only for retired people, age is missing, for example, as an example, right? So then you just leave it as is, or you can take a wild guess and say, I'll just populate it with maybe 75 as an average, right? So these are the kind of things that you want to look at. You look at your correlation metrics, right? And then you come up with insights as to how I want to treat my data. That is point number one. The second is, obviously, how do you look at outliers? That is the second point. Outliers typically have been seen as some sort of data inconsistency, right? But what we would like to think is data outliers are not necessarily a data inconsistency. It is something that needs to be analyzed in conjunction with other variables, right? So that's why we say that look at outliers in conjunction with other variables, right? So what will happen is if you do approaches like DENCLU or a DB scan, right? While they do the clustering, what also happens is they will tell you in an n-dimensional space where is it that point really lies. So as an example, what would happen is if you take a variable, right, and then you look at a point which is at the 99.5 percentile, for example, right? But then you plot it along two other different variables, right? There's a very high possibility that this variable might not be in the 99th percentile in the other variables as well, right? And might be in the center actually for all given purposes, right? And then what the other thing that you can analyze is if you look at maybe a simple distance calculation, maybe a Manhattan or a Euclidean distance, right? And you look at it in the context of all the three other variables, and you figure out that in the neighborhood there are no other points for that particular point, then that is where you see that there is a differential behavior that is coming in, right? I mean, so it's a simple point where you could have thought that there is an inconsistency in data to a point where you're thinking that while it is an outlier from one aspect, from the other aspect, it's not really an outlier, but there is differential behavior which is happening, right? So maybe you want to analyze that. We would like to think that you actually capture this information and use it as an independent variable when you're building the model, especially when you have a divergence of behavior in models like fraud, for example, right? You want information like this can be very, very useful. You take these points and put it as a independent variable and try and see if you can model this information and create models accordingly, right? So these again are things which we are looking at how we can automate, right? So you look at variables which are highly correlated to each other, and then you do your either MAR analysis or anomaly detection, right? The other things are, I think, fairly basic. I think you look at things like information value to look at interaction between the independent and the dependent variables and see which are the variables which are giving you good signals, right? And the correlation matrix is obviously to look at correlation, right? So I think what we would like in an ideal situation, right, is to automate all of this and the results to come out, say, within a 3 or 4 day time frame, right? Obviously, I mean, there's going to be a little bit of iterations because you might want to look at multiple permutations and combinations. But let's assume in a situation where instead of a 2-month time frame, you've brought down the entire time frame of this analysis and you've brought it down to say a 10 or a 12-day period. Then I think that's a lot of time that's been saved, and then you can really work with the business, right, to possibly fine-tune how your dependent variable is defined and things like that. So I think that's where you typically tend to save a lot of time.
So what we are doing is, to add to what Raghavan is saying, is that we are having engineering teams which are basically looking at, for example, how do you do univariate and bivariate. One of the simple things we have done is write code which can kind of auto-understand what the data is, either through the metadata, which if it's provided is great, otherwise through scanning the data itself. And then once I know what kind of a data type it is, I can then classify that into specific sub-buckets and use those sub-buckets to say, can I do a bivariate or a univariate? So if it's a continuous real number, then I know that I could do a univariate analysis of it. If it is a classification, then I can do a slightly different classification tree to kind of start looking at insights which can be generated as reports automatically. So users, which is the analytics science team, can actually come in at the second stage to say, the data has already landed, we have kind of done all this processing, what is the first round output that's coming out of this? The last point is a very interesting thing that we also see that, typically the way we see science is, there is the model building life cycle, and then there is the scoring life cycle, which is the business rule life cycle when it's really applied in real time or runtime. And what we see is, when we are building the runtime pipelines, we are seeing that there has to be 3 pipelines actually. It's like city planning. If a city is badly planned, you only have 1 layer of planning. We are saying that in science, the topmost layer is the scoring framework, which actually provides value to business, right? So when a new customer comes in, how do I classify him in terms of whatever is the business use case? If it's from an attrition perspective or if it's a segmentation perspective, that's the first point. And that will be the core model that will run for that specific business scenario. But below that, what we are saying is, as the data comes in, can I do a validation pipeline? So validation pipeline would be as the data comes in and I kind of score it and go through various interim steps, do validation whether it's on the data side or it's on the model side. As the model changed or the data population changed, shifted, which therefore would invalidate the scoring itself is something that we are trying to build into our code. And finally, we're also trying to see one of the challenges for the future would be performance and scale. We're also trying to build as much logging and tracing in the whole code so that we can also see what is the performance characteristics of the model as it runs. Most of the models we run, interestingly for AIG, are what I would call near real-time batch processes. So we are not really running something like Twitter which runs real-time. So we are running more batch processes. In that scenario, this actually becomes even more relevant for us, where we take possibly a daily process and run it through the scoring framework, and then comes the outputs which are then piped into various business processes. So that's how we are kind of looking at it from a software architecture perspective. Possibly, yeah.
Just one point. Actually, the point where we spoke about understanding the data type is an extremely important point because even when you want to do a simple correlation analysis, depending on the type of the variable, you either do a correlation or you do a chi-square or Kramer's V, right? That is the one part. But also when you progress into the model building phase and you've done pretty much done with all of this, right? When you've created the first level of data set, right? How do you want to use your the categorical variables is another question, right? So do you want to convert them into a dummy variable, right? Or you want to just use them as is, right? So we are trying to reach a stage where we could say that given that this is the type of data that I maybe have multiple dimensions, maybe more than 200, right? And I don't want to create more dummy variables, and hence I would maybe use a algorithm like decision tree or random forest, which would be able to process the data as is, or maybe a naive based, right? Only when I'm comfortable enough, that I want my dimensions to go bigger, and I'm okay with it, then I'll possibly convert all my data into a dummy data. We have automated that part also. So you just take a variable, create those dummy variables, and then you run maybe something like a KNN or an SVM, which is able to process all that information, right? So that's just another point that I wanted to add to the data type understanding being important at the first stage itself. Yeah. So any questions so far?
Yeah, how do you automate the process of finding whether it's missing by random or?
So you have to do a little bit of an analysis. The stage where we would get to is we would look at which variables are correlated with respect to that particular variable which has missing values, right? So we would start off with that, and as I said, right, it is more of a categorical analysis. So which is the category which is contributing maximum, given that a variable has missing value, is what you will tell. But then what we also want to look at is maybe what are the top 3 or 4 categories across different variables, right, which are contributing to that. So this is more of a recommendation that will come out for the business. We can have a discussion with business because ultimately the business has to take a decision. So what we do is once we come out with the recommendation, say these are the top 5 points. What do you want to do? I think we would give our recommendation. The business would say, I think we are comfortable with this, or we are comfortable with this. Right, so I mean, it's not completely automated in the sense because I think we still need to have that human touch. I think that's a valid point, yeah.
Yeah, the idea here is to do all the preliminary steps which are repetitive on an automated pipeline. And then the analytics people come at a point where the reports are already out, and then they can use that for their workshops with business to say what they do and how they build the model. This is the first time or the iterative time when you're kind of maintaining the model, right? So that time you'll anyway have to do it.
So building on this would be, so this would be for a generic or for specific domain or across the domain?
So
You can
ideally should be generic, but we have not reached that level of idealism in sense of our code. So we are looking at specific areas and trying to reuse. The whole genesis of this comes from the fact that we want to reuse the code, and we also want to be faster in responding to business, because business typically hears timelines like 3.5 months to build a model or 4 months to build a model, and for them they're not very comfortable that a model is getting built in 4 months and possibly getting deployed after 8 months, right, into the business, because there's another pipeline of taking this back to business. So they want it faster. So that's the possibly where all of this kind of starts up. Yeah.
So my question is this running off the available pipeline frameworks, deployer, Cypher, or Spark, or are you building your own?
No, we are using a lot of existing.
So typically what do you use?
So we are surely using Spark. We are using
Spark
Cypher.
as a pipeline framework, a specific
Yes.
pipeline framework.
Yeah.
Which we are using.
We are using Python. Cypher
Pipeline
variant.
framework.
Very much.
See, all of them have the same problem. There is no conditional logic available to you at any point
That is where we write the custom code, where we can.
How do you build that in with the pipeline framework that you plan provides?
So that depends on the specific use case. So what we do is we for example, if you take a simple thing like data type discovery, right? So the data type discovery is a standard available of Python.
Conditioning is available in the native deploy, right? You can have that if underscore else, which is introduced at a variable level.
Correct.
But at a data set level, there is no conditioning possible. That if this is true of the data set, do this. If this is true of the data set, do
That
this.
is what we write. So what we do is the result sets that come out, there is some custom code that we write. What we see is the custom code is a stitcher between already existing modules available in the market. So obviously our teams are, it's like a research lab where we kind of go and look at those specific libraries and see what we need to write around it. So we are writing wrapper code around
So
it.
basically, the reason is because pipelines are essentially composition of functions, right?
Yeah.
Anytime you introduce conditioning logic, you're basically breaking the elegance of the framework. You're basically writing glue.
Could be. I don't disagree with you, but what I see significant value here is what traditionally was taking significant amount of time, we are able to compress it down. Second thing is we are able to, one of the things we are abstracting out is we are taking all the configuration variables out and putting it as configuration files. So tomorrow I need to kind of look at a different folder and set of data. I can use a different set of configuration files in the same code. So these are the two things that we are surely seeing as being applicable for this role. Yeah. I'm not saying this is a very elegant product which is ready to be open sourced or sold. It's not. But then what I'm surely seeing is it's a pathway towards science for the future in business.
So just
Here's an example. Possibly Aga will talk about it a little bit.
So this is an example of a recent model that we had built. This was about some of our customers were surrendering their policies, right, or doing some sort of partial surrender. So we wanted to figure out if you could obviously assign a probability to them and make some sort of a preemptive action, maybe contacting them in advance or giving them options, right? So the entire process was obviously run through whatever we had spoken about in the previous slide, starting from your data understanding, coming to the point where you understood all the interactions between the variables, right? So we took this and we used a spline-based logistic regression in this particular case, and obviously this was a very particular, obviously there are other techniques also that we could have used, but I think what business wanted was to take one particular variable and understand the effect of that one particular variable across all the other variables and use that in the model, right? So that's why we had to use spline-based logistic regression, right? For those of you who don't know, spline-based logistic regression is basically an extension of the regular linear regression model, but what it does is it basically helps you understand the distribution at different nodes, right? So for example, you can see this has a different shape, this is fairly straightforward, this is monotonic, right? But then this is more of a quadratic shape, right? So what it will help you do, a regular spline, what it would help you do is you would be able to maybe have an equation which is y is equal to a plus bx square and cx, right? And then here you would still have the y is equal to a plus bx equation and some different equation, right? So then what happens is, and then you've basically split that variable into different nodes, right? Now there are, for what we've used here is a simpler version of the spline. There are other techniques also. There is B splines, there is adaptive splines. Adaptive splines will pretty much help you understand the distribution and create nodes, right? In this case, I think because we had looked at the distribution, we are fairly confident that two splines would pretty much do the job. So we had taken two splines and then we had used other variables and then done it, right? So the other thing that we wanted to understand was, given that, as I said, right, business wanted to understand just this one variable and use it to understand what is the effect on the dependent variable. So we had taken one variable x, right, and then other y, z's, and we had looked at the interaction. So you just multiply the interactions, right? And then you look at what is the effect or what is the surrender rate, impact of this interaction on the surrender rate, right? So that's some of the variables that we had created was x1 into x2 in the model itself, right? So there were x squares and then x1 into x2 and things like that, combinations. And then finally what we got was the model, and we basically had the gains curve created. The Gini was around 41%. Not a fantastic number, but I think given how complex the model was, I think it was a decent number. The one thing which I want to point out is, especially when you're doing splines and you're doing higher order splines, the general recommendation is that you use regularization as an option, because what tends to happen is if you have beta's values very high for the higher order polynomials, right, then the model typically tends to overfit, right? So it is always recommended that you use some sort of regularization and restrict the beta coefficient so that the overfitting is taken care of when you're doing a model validation. Yeah. So just an example of the model that we had recently built. I think now Vish will talk about the integration part.
So the other area we see is the second area is basically the data integration pipeline on top of this, especially during model runtime, where once you build a model, you want to kind of then start storing it regularly for business. Then how do you do it? So some of the things that we have surely seen is one is doing, like I talked about the 3 layers. The second layer, which is DQ, this data quality. As the data comes in, new data which you want to use it for business, run it through a data quality and validation scoring framework to make sure that the data is representative of what it needs to be before it goes for scoring. We have obviously used Kafka, which is quite useful in terms of distributed messaging queues when there are large data sets. We are today working in the scale of 10 to 50 terabytes. I would not call that the largest, but then for AIG's infrastructure, it is still significant in terms of what we have achieved till date. So we do use Kafka there, largely when it is distributed. We are also kind of building simple data transformation algorithms before we get into the model, both on the data source side and also on the Hadoop distributed infrastructure side. One of the things that I surely see being important is in these pipelines, and especially when you look at turnaround time, is important is to look at network I/O and disk I/O. What we have found is whenever network I/O becomes high, especially in a data center environment where network is a common resource being shared by many other systems, then that becomes a big bottleneck in terms of throughput times. And interestingly, our experience has also been that when the throughput time increases, the reliability of the system starts dropping down. So we have seen models which run for 2.5 days initially, and therefore the reliability is very low because there are a lot of failure points within the collective data center infrastructure which causes the model to fail. Whereas when it gets compressed down to a couple of hours, then the reliability of the system increases rapidly. So from an engineering perspective, we see that ensuring network I/O reduction is very important. A few guidance factors there is, one is be sure that the data you're taking is completely relevant to the model. If you want to do any scraping, do the scraping. Do zipping for transfer if you're doing batch transfers, so that the network I/O is reduced significantly. These are all certain things that we're surely doing between systems. So that's a few things that we're surely looking at. Going forward to the third area is basically once the data is inside the system, how do you then handle scale and compute? Our experience has largely been in the Hadoop MapReduce and the Spark space. We have also looked at some amount of software engineering in terms of, like I was saying, how do I abstract out some of the configurational aspects of the code? How do I look at, to some extent, look at abstractions and object-orientedness in the code? Largely, science teams tend not to build thinking through software engineering principles, and we're trying to bring those aspects. Again, network I/O and disk I/O is very important even within the cluster. It's very important that you're not moving your data around. So localized data compute is a significant thing that we are seeing. The final point I would like to bring out here is have a continuous focus on benchmarks, largely looking at do benchmarks continuously regardless of what the size of your data, both on design time and runtime. Because that helps you scale up in the future. So initially the data sets are smaller, and as it grows, do you need to kind of change the architecture, or do you want to bring a different size cluster is a very important thing. The table here is a very interesting table which has influenced us from an engineering perspective very much. It is basically the response times of various hardware elements in your data infrastructure. This is Jeff Dean's back of the envelope thumb rule from Google, and it clearly shows how if you don't think through this, a lot of the models that we run without really understanding what's going on at the hardware level causes a lot of latency and therefore reliability issues. So just look at it. L1 cache is just 0.5 nanoseconds, all the way to a packet round trip between two locations being close to 0.15 seconds, right? So that's all nanoseconds. So that's the kind of scale difference in terms of how hardware elements work. Because at the end of the day, all of this compute is actually happening in the hardware. And we tend to kind of look at how we can kind of push things up the chain in terms of run as much of it in the top components rather than kind of bringing it down to the disk or network. That's one of the principles that we tend to kind of follow in the automation pipeline. Finally, the other area that we do surely see is a lot of people are talking about science and visualization as a human interface. We see a lot of our models being a lot more relevant to business when they're integrated as an API into various other business systems. Some of the areas that we have surely kind of touched upon is to kind of build mobile application wrappers for some of the models, which can then be used very much like all the Web 2.0 companies. We've also looked at API publishing so that other parts of the organization. This goes back to the conversation, I think, the presentation that was being done in another session where he was talking about a smart data lake. Right? I think it was Prasad from Haidang. And we were saying that how a single infrastructure is extremely important for the enterprise so that everything is in a single place. We kind of, as an additional concept, is to talk about once that capability is there in the enterprise, how can you then provide APIs so that process flow automation systems can consume this as business rules. That's the thing that we are kind of looking at. We also see a significant amount of work in the area of microservices architecture. We have built a few small microservices,